Hello, we are back. We are going to be talking about transformations of functions. This goes along with sections 2.6 in your book, in your textbook. To start with, there's going to be some vocabulary we need to learn, some definitions we need to copy down. So at this point, it might be a good idea to hit pause on the video. But a transformation, a systematic change to a parent function. These include translations, dilations, reflections, and rotations. So we're going to talk a lot about translations today. Though that's moving a function, actually just picking it up and moving it in a certain direction. We're going to focus on up-down and left-right. We're going to talk about dilations, either shrinking it or expanding it. And we're going to talk about reflections, flipping it over an x-axis or a y-axis. We're not going to talk too much about rotations this year. Hopefully you'll learn more about that last year in geometry. So that's a transformation. A parent function. The simplest form of a function or the original function, just like your parents. Everyone comes from their parents. So a translation, we talked about it up here. It's a shift from the parent function in which all points shift up, down, or to the left or right. So all points will either shift like to the left 3 units every single point, or to the right 5 units, or up 2 and down 10 in that form. And we'll see examples of that. The next set of definitions, again, we're not done yet, starts here. A reflection. A flip of the parent function across the x or y axis. So it's like we're taking something and just flipping it across. Just like you would, like a mirror image of it. Vertical stretch. Stretching a parent function by multiplying it by number greater than 1. So if it's in this area, we're stretching it out over this area possibly. A vertical compression. This is shrinking the function, making it smaller. So shrinking a parent function by multiplying by a number less than 1. So if a function is this big, we're going to shrink it down to this big. So again, if you need to pause the video to get all these definitions, please do so. Now, what does this all mean? We're going to start with the very simple function that we've looked at a lot in Algebra 1. Okay, a line. Now, I have this equation. Right. Y, or f of x equals 2/3 x plus 3. So we've seen that a lot before. And I graphed it. It is the line in black right here. Now there's another function in red. Now that is where our function moved. And if you notice that all the points moved up 2 units. This point went up 2 units, this point 2 units, this point 2 units. We could pick anything on here. This is all moving up 2 units. I could pick this point right there. If I go straight up, this went up 2 units. From here, 2 units. So the whole function is moving up 2 units. Now one way we can express this, and how we're going to express this, our translation, we're going to call it the g of x. Change it from the f of x, we're going to call this the g of x. So one way we can express this is the g of x equals the f of x plus 2. We're just taking this whole function and adding 2 to it. That's it. We see it moves up 2. That's how we account for it. If we wanted to add everything in, we could substitute this 2/3 x plus 3 into this spot. 2/3 x plus 3, and then add the 2 at the end. and rewrite this now. So g of x equals 2/3 x plus 5. And what I did, I just added this 2 and 3 because those are like terms. The slope didn't change. I'm just adding on a number here. If this was going down, I'd have to subtract the number. So our next problem is a parabola. So I'm starting with this one in black. The function is f of x equals 0.25x squared. And there's all these points. Now I see from this point up to this point, I'm going up 1, 2, 3 units. From this point, I'm going up 1, 2, 3 units. This point here, I'm going up 1, 2, 3 units. Everywhere across that function, I'm adding 3. So we could start by writing this as the g of x equaling the f of x plus 3. We're just adding 3 at the end. Keeping the original function, the f of x, and adding 3. Now substituting this in, we can then write this as the g of x equals 0.25x squared plus 3. I can't combine any like terms. That's it. We just moved the whole function up 3 units. Now I'm going to show you a function that you probably have not seen yet or have very little experience with. This one up here. F of x equals the sine of x. Now I'm sure you've seen some of these waves, for instance in science class. Maybe a light wave or a radio wave or something like that. But it kind of just goes back and forth and oscillates up and down consistently. Now if you notice, the red equation, the red graph, looks identical. Except what? If I look, it goes down 1, 2, 3, minus 4 units. If I pick here, 1, 2, 3, minus 4 units. It shifted down. This means that we could take our g of x equaling sine of x, scratch that, our f of x, minus 4. Our original function, we're just shifting down 4. So if we wanted to rewrite this with everything included, we could say, I'm going to move this over slightly. We could say this g of x now equals, substitute the f of x in, sine of x minus 4. It could also be represented like that. Same thing, we're just shifting it down 4. Now let's change it up a little bit. Our original function here is in black. It's another parabola. F of x equals x squared. But if you notice, it didn't shift up or down any. It kind of just shifted to the right. Now how we represent this, instead of adding or subtracting at the end, we're going to add or subtract within the parenthesis, where the x is. So we're going to rewrite this now, because it shifted to the right 2 units. Again, this point went that way plus 2. This point plus 2. This point plus 2. You can see everything changed 2 units. I can rewrite this as the g of x equals, in parentheses, x minus whatever number is in here, a 2. So we need to put that and represent it that way. It goes inside instead. We have to actually calculate that before we do anything else. So shift left to right, it's going to be in those parentheses. Now let's look at this problem. Again, probably a function you have very little experience with. F of x equals x to the third power. Now we have this function in black. It kind of comes up, squiggles over, and then goes up again. Now, what happened this time? This time, this thing went to the left. 4 units. So we're moving all these points to the left 4 units. So when we rewrite this, it becomes g of x equals x minus a negative 4. But this has to change. What's minus a negative? X plus 4 to the third power. This inside the parentheses means it's shifting left and right. If it's outside, it's shifting up and down. And that's the conclusion of translations. So that's the first part of this section. We will talk about we'll talk about stretching things and flipping things in the next video. See you next time.